So this lesson is going to be about how to create a force diagram for our ticker cart lab. So first of all, we need to identify what sort of motion we see with a ticker tape. And I think most people would agree that the car is getting faster and faster over time. In other words, it's accelerating. So the first question you need to ask is, are you going to have a balanced or unbalanced force diagram? So we know that the speed is getting faster and faster. And so for that reason, I'm hoping that most people recognize that we need to get an unbalanced force diagram is to represent that motion. So our first question that we always ask is, one, is there gravity? And the answer is yes, there is. So we know that we need to have a vector showing gravitational force. The second question is it on a surface? And the answer is yes, it's on that track. So we know that we have some sort of normal force, okay? The next question is there a push or pull? And assume that I've already let go of the car. It's just rolling on its own down that track, and so the answer is no. There is nothing pushing or pulling it. So we do not have an applied force. Okay, so no applied force. And I'll tell you the next question is there friction? And this track is actually relatively frictionless. So for that reason, we're going to have no frictional force. So we know that we need to get an unbalanced diagram, and we have only two types of vectors that we need to use to draw that. So how can we do that? So some of you might say, oh, well, let's draw the gravitational pull to be longer than normal force. And the answer is not quite, because in this scenario, where would your car be moving? It will be falling straight down, because clearly this is the direction where you have most of your force. So this one doesn't work. How about the opposite? Let's say you have the force of gravity being shorter than the normal force. Maybe that's a possibility. This one wouldn't work, because in this case your car is going to be flying up. So that doesn't work. So the only thing that really makes sense is if you have a force of gravity, the normal force, because it's at an angled ramp, is going to be at an angle. So it's sort of the first time we're going to be seeing this at an angle. The vectors are the same length, okay? Let's assume this is 3 centimeters and this is 3 centimeters. But they are at different angles. Is this a balanced force diagram? The answer is no, it isn't. And so for that reason, this is the appropriate force diagram for our lab. So what we're going to do is we're going to discard that, and I will get out of this program. We will go into our force diagram lab report, and where you see insert force diagram here, you're going to click that, and you're going to go into insert drawing. From that drawing, you can identify arrows. So we're going to create one arrow this way. Then we're going to create another arrow this way and try to get them to be about equal length. This one clearly isn't, so I want to maybe increase the size of it. Then you're going to click text and label those. So we're going to increase that. See if that does that. And I'm going to write in here, I might get this to be a little bit larger, FG. And this one is going to be with a text, F. Let's try that one more time. And then all you need to do is save and close, and that will insert that in there. And that ends your lesson on how to draw a force diagram and insert it into your lab report.